Hello everyone, I am Vivanchala. Welcome to my YouTube channel, Space Engine. This is a series of short videos in which I will explain some concepts about the universe. As such, theory of general relativity, dark matter, and particle physics. I will upload every day, so stay tuned. I hope you enjoy. Today's topic is our search. The key insight of the last decade is that the fact that moons in the outer solar system are not boring, frigid, and geologically dead worlds. Many of them have atmospheres, geological activity, tidal heating, and are interesting and distinctive worlds in their own right. Based on current planetary models, as many as a dozen of the moons of the outer solar system may have liquid water, kept liquid by pressure from rocks and ice above and heating from the interior. This means there's more to the outer solar system than that meets the eye. If we look at images of these large satellites of the giant planets, they look uninteresting. Cratered surfaces of rock and ice, scarred by cosmic rays and ultraviolet radiation, not even possible for habitability. But under the surfaces, interesting things could be happening. Perhaps the biggest surprise came a few years ago when tiny Enceladus, barely larger than Rhode Island, only 500 kilometers across, was shown to have liquid water under its surface that episodically spouted ice particles as frozen geysers out into deep space. Perhaps the most compelling moon or satellite in the outer solar system, perhaps in the whole solar system, is Titan, the large moon of Saturn. Titan is one of the largest moons in the solar system. It has an atmosphere thicker than air we are breathing and made mostly of the same substance, nitrogen. There is no oxygen, however. The pressure of the Titan atmosphere at its surface is twice that of the air we're breathing right now. We can follow the Huygens landing using actual video shot from the spacecraft as it descended through the smoggy murk of the Titan atmosphere. If we look at images of Titan, it's strikingly Earth-like. We see bodies of water, shorelines, clouds, and rivers, dendritic channels, river deltas, runoff. But this place is utterly unlike the Earth. Water cannot be liquid on the surface of Titan. It's far too cold. All the speculation currently centers on oceans or seas made of mixture of ethane and methane, with perhaps small amounts of liquid water and ammonia. This strange chemical brew could be the loss of biochemistry, but if there's life on Titan, it will be like another stage, utterly unlike life on Earth. At the moment, we have no idea if Titan does or could harbor life. It's even difficult to stimulate in a terrestrial lab with what might be going on in the strange material and the Titan. Titan may be the most compelling target in the solar system for future detailed explorations, but we have known of a few other places which also deserve a second look. In particular, the water worlds. Europa is one of the Galilean moons of Jupiter. It's large enough to have significant radioactive heating from its core, and this heat seeping into the base of the ocean creates a sub-zero, but almost tepid situation where life could possibly exist. There's a mission concept that NASA's had sitting on the shelf for a couple of decades, with no technologies they could not easily be proven, and launched at a cost, however, of several $billions. To go to the surface of Europa, land with a nuclear plant that would slowly melt through the icy surface, and then release a hydrobot to explore the subsurface ocean for life is not very cheap. To do such a mission, scientists speculate on where the thinnest place on the icy surface of Europa might be. We don't actually know where it is, assigning enormous risk to a mission like this because it might not succeed. But at the moment, Europa is not in the highest priority position of NASA for the next decade, so no mission back there is planned. In addition to the planets and moons in the solar system, there are sites of small bodies that are nonetheless very interesting. These small rocky bodies include comets which exist in a nearly spherical cloud extending to tens of thousands of astronomical units, and asteroids between the orbits of Mars and Jupiter, the set of rocky bodies beyond the orbit of Neptune. The small bodies have played a vital role in the history of the solar system, though not chemically interesting. The Murchison meteor, which fell on Australia several decades ago, was recovered within hours of its landfall, allowing the material to be collected without terrestrial contamination. Over 100 amino acids were discovered in the Murchison meteorites, including dozens not used in the form of life on Earth. Amino acids are not purely biological material. They are building blocks of life, but they are the essential building blocks, which leads us to think that life may have originated from outer space. Thanks for watching. Please share your thoughts and ideas in the comment section below. Bye.